time. My name is Bryan. I'm a hardware architect and design engineer out of Intel's data center group. And I work, I've had the pleasure for the last 5 years of working with a terrific group of engineers at Faceook on getting their one-socket servers into the data center. And we've been doing that with our Intel Xeon D line, starting with the Monolake one-socket server and going to Twin Lakes, which is a one-socket server based on Skylake D, or the Xeon D 2100 processor. I like to think that the D in Xeon D stands for density, so the whole play here is to try to get as many cores as possible into a very small volume at low power. And what you see here is a very small form factor. This is we're talking 210 millimeters by 160 millimeters. That's not a lot of space for a server, but we managed to put a good number of features in there. So the Xeon D that you're looking at has 18 cores, has 4 channels of memory, 2 DIMMs apiece, so we got 8 DIMMs altogether. These are registered DIMMs running at 2,400 gigatransfers per second. On the back side, if you come to the Intel booth, you'll see the back side of Twin Lakes. You have 3 M.2s for storage. One of them is can support an 80 millimeter. That's primarily for a boot drive. But there are 2 additional M.2s that support 110 millimeter form factor for general purpose, either storage or whatever you want to put on an M.2. We have flexible networking, so there's integrated Ethernet on the Xeon D. You can take 10 gig KR off of Twin Lakes out to perhaps a PHY on the Yosemite mezzanine card. Or you can take PCIe off of the Xeon D, also off the board to the mezzanine card if you want to use a standalone NIC. So there's options there for networking. Up in the upper left-hand corner, the team managed to squeeze a TPM. That's Intel's trusted execution technology, which allows you to fend off attacks to your low-level software, your BIOS code, your ME firmware, those kinds of things. And then this is also dense I/O, and I go ahead and go to the next slide to talk about that. So this is a block diagram of Twin Lakes. It kind of gives you a bit of a better idea of what's on the board. I want to talk a little bit about I/O, and then I'll turn it over to Damien to talk about what happens in terms of server management. The Skylake D supports 32 lanes of PCIe, Gen 3 PCIe coming off the CPU. And Twin Lakes manages to use all 32 of those lanes.
Yes.
And more. You can configure. So one of the things that we do to make it so that we can fit a full server on the small form factor is we integrate the PCH into the Skylake D package. So we have a CPU complex and a PCH complex, and that PCH has additional high-speed I/O that can be configured for PCIe, SATA, USB, integrated KR, all those things. Up to 20 lanes of additional PCIe, and I believe Twin Lakes uses 9 of those 20 lanes.
That is right.
Yeah, 4 for that boot drive that I talked about, 4 going off to the Mez card for networking, and then there's an additional PCIe lane that goes to the BMC for debug.
And to the VGA.
Yeah, yep. Exactly. Yep.
Okay, so we'll talk a little bit more about how the Twin Lakes interface to the Yosemite V2. Just now you heard about Yosemite V2, and so there's one feature that how we can make that the Yosemite V2 support modularity is we have a bridge IC on the Twin Lakes card. So this Twin Lakes card there is a bridge IC, and then that bridge IC serves as a bridge between the SoC to the BMC. So here our interface are through LPC using through the UR to have all the debug capability, and the BMC talks the bridge IC to the I2C to get the servers, sensors, information, and BIOS actually do also get some information from the BMC. For example, hey, the next card, it is a server card or is a device card? Do I need to train the link or should I just keep myself shut? So those information are transmitted through to the BMC through this bridge IC interface. And of course, the BMC recognize what card it is through the flue and get a temperature sensor to control the fans through this bridge IC as well. So it's an integral part how we can make Yosemite platform to modular is through this bridge IC.
And this is running OpenBMC, right?
Yep, we're running OpenBMC, fully open source.
Yep. Excellent. Thank you, Damien.
Even the bridge IC codes are open source.
Excellent. Just one more slide here. This is just comparing the Xeon D 2100 to the previous generation, the 1500. Really quick, we've added a couple of extra cores to enhance the compute performance. We've rebalanced the caching, added 2 memory channels, a bunch more PCIe, really enhanced the I/O, and added some acceleration engines. We've enhanced the AVX 256 to AVX 512 for your matrix manipulation, and we've also added Quick Assist to do additional acceleration for networking workloads. And with that, I guess the main message here is that in addition to being high I/O, you really can get good compute performance out of this Xeon D small form factor, low power CPU. So finally, I invite you to learn a little bit more about Twin Lakes. As has already been mentioned, the Twin Lakes spec is already up there on the OCP website. And Damien and I co-authored a blog on the Intel IT Peer Network website. Come check that out. And finally, come to the Intel booth. We have live demos going of Yosemite, and we invite you to come and check those out. Thank you very much for staying to the very end. Enjoy your lunch.
Thank you very much.
We'll see you at the booth.